Good morning, good afternoon, or good evening, depending on where you're joining us from. Welcome back to part 5 of this look at rebuilding the HANA OpenSAP developer course using the latest capabilities of Cloud Application Programming Model, HANA Cloud, and doing it all in the Business Application Studio. Now, just to recap what we've done so far, we spent a lot of time talking about modeling using the Cloud Application Programming Model and CDS, and we've built up a pretty robust data model that really showcases a lot of different aspects of new capabilities that we can do using the Cloud Application Programming Model. We've also seen in the most recent episode how we can mix in database level artifacts as well that are modeled standalone in the HDI based artifacts. So HDB table, HDB view, HDB constraint, HDB index. We saw a variety of those approaches. So we kind of want to continue along this path talking about breaking out of the Cloud Application Programming Model. And one of the most common scenarios that people face is the idea of either cross-container, cross-HDI container access, or cross-schema access. So obviously not all the content is going to be self-contained within the data model of our own application. We're often going to need to access data from existing other schemas or other containers. In particular, if you're working with an ERP system or you're replicating data from somewhere else, you have some legacy schemas that maybe haven't been converted to HDI yet. We need a way to access that content from within our HDI-based application, and even going a step further, we need a way to pull that into the Cloud Application Programming Model as well. And that's exactly what we're going to see in today's episode. Okay, for the first part of this episode, we want to see how we can access an existing classic schema. So not an HDI container, something that has been imported into our system or created from scratch as a standalone schema. And we're going to use the SFLIGHT schema because it's widely available. I'll put in the show notes where you can download it and link to instructions on how to install it into your own system, your HANA Cloud system or your HANA Express system. The process is the same. And we're going to use SFLIGHT to basically simulate a whole ERP system. Because the technical way that we're going to access it, the security setup, is all the same that you would have to do if this was either replicated data or a local ERP system, whatever your scenario. This is really going to be very representative of how you would access it. But the SFLIGHT, as I said, is available for free download and can be installed in your trial or HANA Express system. It's not terribly large, only like 70 megabytes or maybe 100 megabytes worth of data, enough to be interesting, but not so much that it's going to blow out the size of your system either. So it's a nice compromise and a nice way to get started. Now, what I've already done in this system is actually when I first built the HANA Cloud trial, if you remember back to that video, when I first came into it, logged in with the DBA admin user, which is very much like the system user in HANA Cloud, and I've already imported SFLIGHT. So if we look at it here, all the tables, there a list to the schema SFLIGHT, they're all here already imported in the system. And if you want to see that step that was done in the previous exercise, in a previous video. Very simple process, though, to import a schema. I mean, it wasn't that big a deal. Import catalog objects, and then I found the file, imported it in, and then I kind of just watched it run. So we have the SFLIGHT schema there. We have all the tables. We have all the data in there. What we need to do now is we have to be able to set up for our project to be able to access it in a controlled way. We need a couple things. We need a user-provided service, because that's going to be the mechanism that will be used to grant access to our container technical users in order to be able to access SFLIGHT, because right now those generated users do not have enough authorization to just directly access the SFLIGHT schema, and you should never directly alter the security of a generated HDI user, because that will just get lost over time. Eventually, through your builds, through your transports or something, that is not going to work. We need to build the grants into the definition of the container itself. And in order to do that, we need a user-provided service that's going to give us connectivity to the underlying database and specify which user we want to use to perform the grants. And therefore, we need a user and ideally some roles that will control the access to the SFLIGHT schema. So our schema already exists. So what I want to do is logged on as a power user, actually the user who imported SFLIGHT, and a user with credentials to create other users. So I'm going to use db-admin for that. I'm going to open a SQL console. And I'm going to run a couple of commands here. I'm going to bring these in from the instructions, but we'll have a look at them real quick. So I'm going to create a new user called cups SFLIGHT for user provided service, and it's going to target SFLIGHT. I'm going to give it a password and give it a valid password, but remember what password you gave it, because we're going to need this in a minute to also set up the user provided service. Then I'm going to alter the user to disable the password lifetime so that we don't have to change the password periodically, because this is going to be a technical user. It's really only used to log in and grant access to our container users. And then after that, it's no longer used. We could actually deactivate it after that if we wanted to. And then we're going to go ahead and grant select on the SFLIGHT schema to this user with grant option, so it can grant it to other users. And we're going to grant select metadata. And I think the other thing we want to do here is, I got another block. We might as well do it all at once here, though. I'm also going to create a role called SFLIGHT container access. And that role will have select metadata. And this role will be granted to the cups SFLIGHT user as well. And the with admin option is basically the same as with grant option, except for roles. It's going to give the user the authorization to also grant this access to other users, which is a key part of the equation here. If you miss the with grant option or with admin option, then none of this is going to work, because your user that you're creating won't have the ability to pass on that access to our container technical users, which is kind of the whole point of what we're doing here. So let's go ahead and run all these scripts. They were all successful. So now the cups SFLIGHT user exists. We've set the password. It has the proper access. And if we want to test it out, what we can go ahead and do is we can say add database with different user. So we'll connect back to our HANA Cloud trial. And I want to connect with the cups SFLIGHT user and the password that we just set. This is no longer db-admin, but cups SFLIGHT. And if we go ahead and connect as that user, this will let us test and make sure that our authentication, our password's good, our user is good, we're logged in. If I come here and I look at schemas, it can only see one schema, cups SFLIGHT. That is all that it has access to in the system. And it only has access to select and select metadata on it as well. So very limited access user here. So next, we want to create the user-provided service itself. And there's a couple of places that we could go to do this. We could obviously go back to the SAP Cloud Platform cockpit and create it via the user interface. But I'm a developer. I'm already here in the Business Application Studio. I can do it from the command line here as well. So using the CF command, so I can say CF services. First, we'll see the list of services that we already have out there. There we are, and we see our HANA database, our trial our ABAP trial, and the one HDI container instance that we've created so far. But what we want to create is we want to create a new service, CF, of type user provided service. So that's the CUPS command, create user provided service. And what do we want to call it? We want to call it cross schema SFLIGHT. And then we have to pass our parameters in as JSON. So I've got this already prepared. So I'm going to copy this. And I'm going to paste that. And let's look at what we have to pass in as parameters. So we have to give it a user that we want to connect to the database with, and that's going to be our CUPS SFLIGHT. We had to give it a password, and this is where I need to change it to whatever password that I entered in the previous step. And I have to add tags HANA. And what schema do we want to target? SFLIGHT. And that's it. I don't have to put in any more. I don't have to put in the host name or port or certificate information. In the early days of HANA on-premise, when we with HDI, when we were creating the user-provided service in XSA, we had to do that. But actually, for a while now, even in the XSA environment, that has not been necessary. The HDI deployer is smart enough when using a user-provided service that if you don't give it the connection parameters, it will default back to the connection parameters of the primary HDI connection. And that keeps us from having to respecify port and host name, and in particular, the security certificate information, which is rather complex because we're using encrypted connections here in the HANA Cloud. And we get all the same security that we would, but it would just inherit it from the primary container connection automatically. If I go ahead and hit enter, it's creating that user provided service. It is done. Let's see if I do a CF services again. Does it list the user provided services here? Yes, it does. It puts it as type user provided. We could also go over, and I'll probably have to refresh here because I haven't used this tab in a while, so I'm sure it logged me out. But if I come back over to the Cloud Platform Cockpit, and I go to user provided services, this is also where I could have created it from here. And if I need to, I could edit it from here as well. You see, there's my password, schema, user, all the same credentials that I just maintained. So it can be edited or created from here as well. Depending on your preference, doesn't matter where you do it, just so it gets created. Now the other thing we need to do, not actually required to use this from the Business Application Studio, but it is required if we were to go back to the Web IDE, and ultimately required if we want to package this entire application as a multi-target application and deploy it. We're going to need this defined as a resource in our mta YAML as well. So let's go ahead and do that. So I'm just going to come here to the resources section and insert another resource named Cross Container Service 1. And it is a Cloud Foundry existing service, so it has to have already been created. That's pretty typical for user-provided services. We give it the name of the service, and then we create an alias that can be used by the deployer. So let's go ahead and save that. Now, the only other part of this that is perhaps a little tricky is we need to also add this to our default-env.json because the default-env.json simulates the bindings, and we're not deploying to Cloud Foundry, so we can't bind the user-provided service to our running application, which would provide all the credentials of the user-provided service directly to our running application or to the HDI deployer. Remember, we're using the default-env.json to simulate all of this, the environment variables. So what we need to do is we need to come in here to the environment variables, and we'll go ahead into this VICAP section where we have a HANA section. We still need the HANA section, but now at the end of the HANA section, we'll just put a comma in here, and we need to add a, ooh, that's not good. I got another section that I want to copy in. I'm going to put in a user provided section, and this is simulating the binding of the user provided services to our application. Now we haven't actually created this other one yet, the images that we'll use later. But that's actually okay. I can go ahead and put it in my default-env.json as long as I don't try to reference it in my code. Then it's not going to give us any problems. But let's actually go ahead and save this. And to the really smart observer, you might think, you know, actually all the steps that we've done up to this point to actually physically create the user-provided service, that wasn't necessary. All I needed was to put it in the default env.json, and that's enough to simulate the fact that the user-provided service actually exists. And that's true. I didn't need to add it to the mta.yaml. I didn't actually need to create it at the CF level, but we're preparing for the fact that eventually we do want to deploy this to CF and run it from there. And we've done the necessary steps to make sure that will work, and just make sure that we don't miss that step later. And also helps with, from the educational standpoint here, you're seeing those proper steps. But in reality, all I had to do is put it in the default env.json, because that's simulating the entire CF environment and the existing services, their credentials, and everything that's in the MTA YAML as well. And it's going to allow us to test and deploy and run from here without actually needing those other parts. Now, the other thing that I want to add in here is I'm going to need some service replacements as well. Now, this is a little bit of magic, if you will, that the HDI deployer uses, so that you don't have to technically hard code the user provided service, or later you'll see the foreign container name in our database artifacts. We don't want hard coding of that, because then the database artifacts would have to change every time we transport them to a new environment. So what we're really doing here with the service name 1 is we're creating an alias for the actual user provided service name. So the actual user provided service name is cross schema SFLIGHT, but in a second we're going to create some database artifacts that use this user provided service, but we're not going to hard code the name cross schema SFLIGHT. We're going to use the name service name 1. And what the HDI deployer will do is look for this service replacements as a cross-reference to map the alias name to the actual target name. Now, normally this service replacements section is built into the environment of our running application by the MTA YAML. The MTA YAML, when it's processed by the deployer, will look here and it'll say, oh, cross-container service 1 is actually pointing to service name cross schema SFLIGHT, and has a property for the service name, an alias for the service name called the service name. And that's all we're doing here is creating this alias. And actually my alias probably isn't right there. It's not the service name. It should be service name 1. Just to make sure those match up. See, that would have worked fine because we're not actually using the MTA YAML at deploy time here, so you have to be a little careful. It's easy to get little mistakes like that injected into your MTA YAML that you don't find until deploy time. But that's sort of the trade-off that we have here with doing this local shell-based development and not deploying everything to Cloud Foundry every time that we want to run something. So we trade off a little bit of validation for speed and turnaround time. But this should simulate the entire process. And remember, we also have our default env.json in each of our folders. So we want to copy that over, and we built this little command, npm run env, that copies the file. So we only changed it once in the default env.json on our root, and then that copied that into the default env.json of the db and the srv folder, so it will be there and ready to work. Now the next step of the process is to actually tell our HDI container to use this user-provided service to perform grants to our container technical users. In order to do that, we have to create a CFG folder in our DB module. And the name is very specific. It's the name CFG that triggers the HDI deployer to know that the files in this folder are configuration files and have to be processed before any of the rest of the deployment happens. So before any of the cloud application programming model objects are created, or anything that we've created in the source folder gets deployed into HANA, the HDI deployer will process this content first. And what we want to do is we want to go ahead and create a new file here. We're going to call it SFLIGHT. The name of the file doesn't matter. It's the file extension that matters. And it's going to be an hdbgrants. And hdbgrants is exactly like what the name describes, grants. It's going to perform grant operations on the container technical users at deploy time. And what we're saying here is use service name 1, which is in our service replacements. So it's telling the HDI deployer, go find service name 1. So it's going to go to the environment, look up service name 1, see what it cross-references to a user-provided service named cross schema SFLIGHT. So then it would come down here to the user-provided service section, look for cross schema SFLIGHT, and then it would pull this user and password out, and it's going to use that to connect to the underlying HANA database. And it's saying, using that connection with that user, go to the object owner technical user for this container and grant it this role. And then go to the application technical user, because remember, there's always at least two technical users created for every HDI container. An object owner, which generates all the underlying database objects and owns them, and a completely separate user that's used at application runtime to access those database artifacts. And we want to give them both this select access to our SFLIGHT schema. Yeah, and that's it. So it's like building a little deploy script, if you will, but in a very abstracted way. And you can imagine, now this hdbgrants, this part of our project, if we transport this to a completely different environment, all we have to do is change the user-provided service name or its credentials, and then in a true deployment, it will point to the correct underlying database. We don't have to change anything in the hdbgrants file itself. At this point, let's go ahead and save this. This should be far enough along that we can do a DB deployment. So let's go to the DB folder and let's do an npm start, and it will test. It will actually perform the grants, and we'll make sure that all the security is working correctly. There we are. It's already done. Let's look at what it did, though. So if we go up here, it says using default-env.json. Using service replacements variables with 2 replacements. So it found our replacements. We can see in the log that it found our replacements. That's very good. If we hadn't had a default env.json, we were really deploying from Cloud Foundry, it would still find the service replacements. It would find them via the binding that was created in the mta.yaml. That's the only difference there. It's seeing that it's processing the config SFLIGHT hdbgrants. That's good. It's using the grantor service name 1 of type SQL, and it processed the hdbgrants. So we know that it granted the security to our technical users, and that's all it really had to do at that point. So it's done. And that means we can now go create synonyms in our project as well that point to the tables or views in the SFLIGHT schema. Before this point, if we tried to create those synonyms, because anything outside of our container has to be accessed via a synonym, but if we tried to create that synonym up to this point, when we deployed it, we would have just gotten a not authorized because our container technical users didn't have any access to SFLIGHT. Now they have access to SFLIGHT, so creating these synonyms should work. So let's go here to the SRC folder, and let me just we'll create a folder named Synonyms. Folder named Synonyms, and inside there we'll create a file named SFLIGHT HDB synonym, and come here to SFLIGHT. And what we're saying is we want to create a synonym named SFLIGHT for the schema SFLIGHT, the object, the table named SFLIGHT, and we're all going to do the same for SBook and SPFLI. So let's go ahead and save that, and let's just run another deploy into the database. And what we should see now is it created those synonyms. Very good. So now when we go back over to the Database Explorer, and not as our CUPS SFLIGHT or our dbadmin, but connect via our HDI container and our container technical users, when we go to synonyms, we should see SBook, SFLIGHT, and SPFLI, and we should be able to read the data from our container. Yes, so now from our container, we can read the data of a foreign non-container schema. So we've now seen how to access a foreign schema from within our HDI container, but that's just step one of the process. Now we need to extend that into the cloud application programming model as well, so that we could access this, say, via our OData service or via CDS annotations. Now to do that, we're going to need to create a CDS file similar to our other data model files. So I'll just come here and I'll create a new sflight.cds. But we need what I tend to call a proxy entity. An entity that redefines the table and all the columns and the data type at a level that CDS understands, so in the CDS syntax, but does it with a special annotation. And let me show you the result here, and I'll show you how I got to it. So what I need here is I actually have, I define an entity named SFLIGHT, and I add the special annotation at the beginning that says CDS persistence exist. So that tells CDS and the CDS compiler not to create or recreate this database artifact, to not create an HDB table for it because it already exists in the database. But what we're doing is we're giving it all the metadata definition so that so it will generate the metadata that we need for the OData level or the association level to access this entity through the rest of our cloud application programming model semantics. Now, the downside to this is you have to redefine both the entity and all the column names, and you have to make sure that you match them exactly. And sometimes that could be difficult if the semantics that you use in the database, because the HANA database will let you use upper and lowercase. Not a problem here because this table that we started with did not use upper and lowercase. It only used all uppercase. So this conformed to the CDS standards. Sometimes you might have to build a view at the database level to change the names of things so that they will comply with the cloud application programming model naming rules, where we have to have everything all uppercase here. Now, if I would mistype one of the names, if I get the data type wrong, it would not throw me an error at build time, unfortunately. It would not be until I go to try to use this, say in an OData service, I would get a runtime error. So it does not catch it until then. So one thing that that you can do is the HANA CLI tool that we've given out as a sample code has a feature that will help you with this. So if I say HANA CLI inspect table, and if I then say, I think it should ask me table name SFLIGHT. Oh, I should probably put, I should put the schema name. So actually, if I just say SFLIGHT, or schema SFLIGHT, table SFLIGHT, it will go and it will inspect the table. But one of the output options on this inspection, if I do a -O, is I can say CDS. So it will inspect the table. It will convert all the metadata into CDS syntax. So I don't have to retype all this. This is actually how I generated what you see here on the screen, the SFLIGHT definition. I did not type that by hand. I used this utility to convert it from the existing catalog metadata. That's all this utility is doing. It's going and reading the existing database artifact and then performing the logic to translate this into CDS so that we don't have any errors. And by the same token, I could come here and do the same thing. I want another entity, but let's do it via the tooling. Let's say sbook. I want to pull in sbook. There we are, all good. And I'll just cut and paste this. There we are. And then put this as another entity, and there's sbook. If I want it, I can format it so it looks all nice. There we are. We have our two proxy entities. But we don't have to stop there. Now that we have these proxy entities exposed to the CDS layer, is we can use them in more advanced semantics. For instance, I can come here and I can begin building views on these semantics on these entities as well. So basically, I'm going to build a new view called SFLIGHT view as a select from flight table, which is really just SFLIGHT. I've just created an alias for it. I can even add associations using the mix-in concept again. So I'm applying associations on top of non-CDS generated entities. I can add restrictions. So this is going to add really just a structured privilege into the database. For this additional view on top of this as well. So that'll get us into some of the more advanced security that we want to do here down the road as well. So let's go ahead back up to our main level. Let's do a CDS build. Oh no, not yet. I keep forgetting. I got to add this to my schema CDS using from schema SFLIGHT. Are. Now I can do a CDS build, and it compiled all of that, and what we should see is we should now also have flight, HDB view, but it did not create HDB tables. We don't want it to create HDB tables because those tables already exist. We only want it to generate views at the CDS layer on top of those existing database tables. So that all looks good. Now the only other thing that I want to do here before I deploy this all into the database is I just want to show you that we can also build a view ourselves. We don't have to, we're not forced to use Cloud Application Programming Model to access these tables via Synonym. I can also go into the database sources. For instance, I'll just come here to data and I'll create a new folder called SFLIGHT. And inside there, I'll create a SFLIGHT view.hdb view. There we are. And I'm just going to create a view at the HDI level on top of the on top of SFLIGHT. So you see here, oh no, that references another object. Where did I have that? So I'm building that on top of Flight, SFLIGHT ext. Oh, I see. Yeah, I remember what I'm doing now. I actually decided here that I wanted, so I've got define view, let's see, Flight, SFLIGHT view. So we got the, from SFLIGHT ext, that's the SFLIGHT ext. There we are. So I have this view that I've defined in CDS, and now I'm building an HDB view on top of that as well. So another layer view, this time with a structured privilege check as well. So another layer of database level security checking here as well. Just layering up a couple of different examples, but showing you the flexibility and the options that we have here. So now that that is created, I think I have everything that I want. I've already done a CDS build. It's good. So if I go in the DB folder and do an npm start, this will deploy it all into the database. So 3 new files. It did create our 3 new views in the database. So that's good. That's exactly what we wanted it to do. Now if I go over to the Database Explorer, and I look at my views, I should have 2 views named Flight. These are the 2 CDS views, and then we would have one named SFLIGHT view. This is the one that we created with the HDB view. So let's start here with the SFLIGHT view. This is the one, this is the first one from CDS. So this is the one without the restriction on it. So we should be able to see all the data. And if we run that from the Database Explorer, SFLIGHT view, we can see if you were interested in the create statement, just creating a view using the outer joins generated by the associations. We'll go ahead and do an open data on that. And yes, I can see 1,000 rows. Basically see all the data. Very good, following the associations. So I've got SFLIGHT and SBook data. And even if I wanted to select, let's just change this, select count star. Curious how many records are in there. Oh, we got a lot of records, 1.3 million records. Okay. Now let's look at Flight, SFLIGHT ext. Now this is the one with the restrict read grant where client equals, and if I run this one, I should get all the data again because that is restricted at the Cloud Application Programming Model. SFLIGHT ext. So yes, I'm still able to read all the data, but if we were to access this entity via OData, we would have a restriction applied. But now if we go down, the last test here, the SFLIGHT view, remember that's our HDB view that's built on top of the other Cloud Application Programming Model view, but we added a with structured privilege check. And if I run this one, open data, this is exactly what I expected to get. Insufficient privilege, because our technical user does not have the structured privilege that we've just assigned to this view. So now we are applying, through the Cloud Application Programming Model, we have security that we can apply, but it doesn't filter all the way down into the database. We have now applied an extra layer of view with database level restrictions on it as well. So next, let's see how we can give access to our technical user so it can access this portion of the view as well. So most of the security in the HDI container is automatically generated. But now we've gotten to the point where we want to alter that that automatic security and define the security for our technical user within our container ourselves. So we're going to have to take over the complete definition here. That means we're going to have to create a couple of artifacts at the database level in our source, in our SRC folder. So the first, I'm going to want to create a new folder here. We're going to call this roles. And I'm going to start here. Let's start by creating the structured privilege itself. As we said that we wanted a structured privilege check on that view, but we need to define what that structured privilege is, and we do that via a separate file here. So we're going to call this SFLIGHT priv HDB structured, and it's important to spell this right. The file extension is very long. It's easy to make a mistake. Structured HDB structured privilege. There we are. I have a tendency to make typos on those very long ones. And the definition here is we're going to say, yes, define a structured privilege named flight view privilege for select on SFLIGHT view, the view that we've already created, and we tested and we saw that we got a not authorized. And we want to add a filter criteria to that to only allow us to see data where the client is 001. And we had many different clients. That's part of the key of this particular tables that we're building this view on. We're going to narrow the amount of data that can be viewed here. And of course, we could also do something dynamic where we could pull in the client from a session variable or something like that. But to keep it very simple without having to set up a UAA and configure the session parameters and things like that, we're just going to hard code a value for educational purposes here. And actually, I want to make sure that I did this right. I'm going to go ahead and do a npm start and make sure that it picks up my one new file. Now I did something wrong. What did I do wrong? Configuration does not define a build plugin for HDB structured privilege. So it's telling us that I got the file extension wrong. So I'm going to cut and paste the file extension. I have a feeling I did. Something doesn't look right there. So let's do a rename. Yeah, I did. I had a typo in there. And this is the error you get. If you typo the file extension, it's going to tell you there is no compile unit for the file. No build plugin exists. That's its way of telling you, I don't know what to do with that file extension. So I've corrected that now. I thought that did not look right. It's a good mistake to make because it's a common mistake, and it's good that people see how to correct it or know what that means when you see it. And now everything's fine. So it created my structured privilege, but just creating the structured privilege is not enough. If I were to come back over here and try to open data again, nothing will have changed. I still get an error there, an insufficient privilege error. Because although I've now defined the structured privilege, I haven't given it to my technical user yet. And in order to do that, we're going to need a couple of roles. So first one, I'm going to create an SFLIGHT HDB role. And this is going to be focused on just giving this privilege out. So just giving out this flight view privilege. So anybody that has this role will also get access to this privilege. So we'll go ahead and save that. Now we want to give this role to our technical users and potentially to any other users that might access our container. So we're going to create an admin HDB role. This is going to be for our main container user. And at this point, not only do we have to create a role that has our new analytic privilege or its role in it, but we have to duplicate all the basic security that comes from the HDI container, because we're going to completely override it and say, instead of giving the default access to our HDI technical user, give it this role instead. So that's why I had to do schema privileges, select metadata, insert, execute, delete, update, debug, create temporary table, because without that, I'd be stripping away things that our container technical users need. Now I'm also going to create another role here called admin owner.hdb role. And this is going to be for the container technical user. You have to give it a role. And the secret to the owner roles, they have to end in pound. That's buried deep somewhere in the documentation, and a lot of people miss it. I'm not the biggest fan of secret naming things, or special meaning or special powers given to things that are named a special way, but that's how this works. It has to end in a pound, and what that means by ending in a pound, that allows any user who has this role to also assign it to other users. And as the admin owner of the container, it has to be able to assign roles to other users. That's the user that will fire when you call the HDI APIs to perform grants. Ultimately, we're just giving it everything that's in the admin HDB role, but we're adding on that extra with grant option or with admin option that we saw earlier when we granted the manually created role to our CUPS SFLIGHT user. Same concept, just a slightly different way to do it via the design time artifacts. Now, the last part of this, it's another thing that has to do with very specifically named things. Another thing that I'm not crazy about. But you have to create a folder named defaults, and inside that folder have to create a file, and you have to get the name exactly right, default access role.hdb role. And with this very specific naming, that will cause the HDI deployer to see this and override the default security and instead use whatever you supply here. So I'm going to go ahead, and it's syntax just like any other HDB role, but I'm saying use default access role and give access to admin and SFLIGHT. Okay, I think we're pretty good now. I'll save that. Let me check. Yeah, I think we're good. That's all the security setup. So if I do an npm start, assuming I didn't make any other typos in file extensions, no, that's good. A couple things that we'll see here. Nothing new there. We're getting here. So it's preparing the files. So it sees our new role files. It's going to create the roles inside our container. That's good. Nothing super fancy going on there. But the really key thing here is you can see down here at the end, default access role file, default access role, scheduled for deploy. The global role access role will be adopted. So it's adopting our definition of the roles into the standard roles that were automatically generated and assigned to our container technical users. So we've just altered that container user. So now connected as in the Database Explorer to the HDI container, we're of course connected as the container technical user. If you don't believe me, I'll do select current user from dummy. There, see, that's the user we're connected with, the _RT user. But now, if I go to this view that was giving us insufficient privilege, now when I select from it, do an open data, fingers crossed, yes, now I can read the data, but I don't read all, what was that, 3 million something rows? I only got 12 rows because we got an automatic row level filter applied as part of the security as well, because by having this role, I'm saying I only have access to part of the data. I only have access to to the records where the client value is equal to 001. So we've done instance-based filtering, role-based row-based access here, something that has a long tradition in the HANA world, traditionally has been applied via calculation views, but we see how now we've applied it to our cloud application programming model generated views by applying a database view with a structured privilege and then extending the core security of the HDI container definition itself. So once again, I'm afraid I slightly overestimated how much I could get done in an hour's time together. I know last week I had promised that we would look at both cross-container and cross-schema scenarios, and we only had enough time today to cover the cross-schema. But I think we also went deeply into the subject and talked about security at this level as well, structured privileges, and how to alter the security of your container users to leverage structured privileges. So that was an important addition that we could not just skim over. But this does mean that next time we will definitely start right away with cross-container access as well. You'll see that the process is very similar to the cross-schema access. Logically, we're going to need a grantor file, an hdbgrants. We're going to need synonyms, and then the process to expose those artifacts to the cloud application programming model is going to be essentially the same as well. But what will be different is we will not need a user-provided service. We will not have to manually create a user to power that user-provided service, because you're going to see how we can directly point to other HDI containers via their servers, their service instance. And that's what we're going to do. The main thing that we're going to do next time is add a second Cloud Application Programming Model DB module to our existing project, and we will build it into a separate HDI container instance. So a very a bit more advanced topic. Almost all the samples you see just a single container in an application, but you can actually have multiple. We'll look at how to do that, and then we'll look at how the two HDI containers in our same project can talk to one another.